Hello, my name is Austin Williams, and this is my final demo for Intro to Feedback Control. So I'm just going to be explaining the tuning process of the PID and results from running the simulated and physical system. As far as the setup, my previous video can be referenced as to explaining the setup of this. So for tuning, I have a MATLAB script where I can input the proportional, integral, and derivative values, run it against a unit function, and just plug in different variables and see what output I get. And then plugging that into the PLC to see how the physical system responds. So I just ran so I found that with these values gives me a pretty clean graph, as well as a good physical system response. I have tried using a little bit. I've tested different settings, so I've tried some with a slight overshoot and a high derivative to force the settling or minimize the steady state error. But I found that this critically damped system works best. I've also tested with slightly lower damped system, so but this seemed to be the best parameters when testing the PLC. So in this, I have a watch window watching all the parameters, and I can also log all of the parameters as I'm running it. So I'll show it running. So you'll notice a speed change. It's going to essentially, at the beginning it has a set speed, then the master is going to double its speed, and then it's going to slightly lower the speed and then lower it again, so we can see how the system responds to a disturbance. Here we log all the parameters. You can see this is our speed variable. You can see we're causing a disturbance. This is our slave speed. Up here is our set point, and then this is the process variable. So I can run it, let me run it again, and we can watch the window as it's running. I messed up a little bit on the physical system. So I would like to point out, whenever I tested with the critically overdamped system, the slave speed had a higher frequency. and the physical system didn't work that well with it. And so I noticed that while logging it right here, I could see the high oscillations, and so I knew to go back and test different parameters. So after I found what parameters worked, I saved the log, and then I have a second MATLAB script. Let me just check that the parameters are all the same. So I have another script that will plot the physical versus simulated results given true values instead of a unit function. And so our red graph is our physical system, the data from the PLC, and then the blue graph is the MATLAB simulated result. As you can see, we are pretty close with the physical system having a slightly higher steady state error.